So yes, dear students, let us do question number 6 now. If I look at this question, we are being given with a triangle and it's a right angle triangle. We have to find the value of W, that is the angle of elevation, I could say. So here, if I look at it, definitely we will be using the concept of Pythagoras theorem here, as well as the concept of inverse trigonometry or trigonometrical values, right? Let us try to solve it. So here the question is, the diagram shows a right angle triangle. We can see it over here, it's quite visible. Find the value of W. To get the value of this angle W, we are being given with the sides of the right triangle, and they are given in terms of some variable t. So we are being given that the base of this right triangle is 5 centimeter, while the perpendicular is t centimeter and the hypotenuse is 2t plus 3 centimeter. So let us first use the Pythagoras theorem to get the value of the variable t, and then we will use it further to get the value of another variable, that is w. Let us start doing it, guys. So here in the given triangle, let us first, much better now, in the given triangle, we know by Pythagoras theorem 2t plus 3 whole square is going to be equal to 5 square added with t square. How did we get this? By Pythagoras theorem. Isn't it, guys? By Pythagoras theorem, we can generate a relation between the sides of a right angle triangle. Let us open this. So 2t plus 3 whole square is same as a plus b whole square, which results into a square plus twice of ab plus b square. So a being 2t here, its square would be 4t square added with twice of ab. So 2 times 2t is 4t, and 4t multiplied with 3 will be 12t. And then b square is going to be 3 square, that is 9, is equal to 5 square, that is 25, and t square will be t square itself. Now let us bring all the terms to the left side and keep right side as 0. So 4t square plus 12t plus 9. So this 25 comes here, becomes minus 25, and t square comes here and becomes minus t square equals to 0. Now 4t square and minus t square are like terms, so they will be getting solved. So 4t square minus t square is going to be 3t square. This is going to be plus 12t, and 9 minus 25 is nothing but 16. So we are getting this in the form of a quadratic equation, and we know how to solve quadratic equation. We'll apply the quadratic formula. What is the quadratic formula? We know that if I tell you for the time being, for an equation ax square plus bx plus c equals to 0, we know that x is equals to negative of b plus minus under root of b square minus 4ac upon twice of a, where b is the coefficient of the middle term, a is the coefficient of the first term, and c is the constant. So here if I equate it with this one, I see that in place of a we have 3, while b is 12 here, and c is minus 16, and here the variable is t. So by applying quadratic formula, what would we get? We will get the value of t to be minus b, that is minus 12, plus minus under root of b square, that is 12 square, minus 4 times a times c, that is 4, multiplied with a, that is 3, multiplied with c, that is negative 16, upon twice of a, that is 2 times 3. This is what it looks like. We have used the quadratic formula. Now we will solve it to get the desired value of t. So here this implies that t is equals to minus 12 plus minus, what is going to be the square of 12? It is going to be 144. 4 times 3 is 12, and 12 times 16 is, if I am not wrong, 192, and negative negative becomes positive, so it is 192, and here 2 times 3 makes it 6. So we are getting somewhat like this. Let us further solve it. Here, if I solve it, I'll get the value of t as minus 12 plus minus, this is going to be 336, so root 336 upon 2 times 3 is nothing but 6. Let us quickly find out the value of root 336 by using our calculator. Let us use the calculator. So when we divide root 336, or I should write or get the value of 336, it is going to be under root of 36, wait for a minute, yes, under root of 336 is simply 18.33, and this will be further getting divided by 6. So guys, we have a plus minus sign. That means first we will take minus 12 plus 18.33 upon 6, and in next case we will take minus 12 minus 18.33 upon 6, and we'll get two values of t. Let's come to that part. T is equals to minus 12 added with 18.33 upon 6, or t is equals to minus 12 minus 18.33 upon 6. So if we solve it, we'll get t here as minus 12 plus 18.33 is 6.33 upon 6, or here we are getting minus 12 minus 18.33 would be minus 30.33 divided by 6. Let us quickly find out the value. If I look at it, I am going to get value of t as 1.055, and here I'll get the value of t as minus 5.055. So guys, we have two values of t with us right now, and which value should we take? Can we take both? No, because t is representing the height of this triangle, isn't it? What is t actually? T is the height or the length of this side, and length of side cannot be negative, so we will not take this negative value of t. So t is going to be 1.055. What is t? This implies that t is equals to 1.055 centimeter. We just got the value of t. Now we will use this to find the value of w. I hope you are being clear with this till now. Yes? If yes, I'll just shift it a little bit to my left so that we have more space for our working, right? Meanwhile, you can write it down. I'm giving you a minute. So yes, I hope it's done. Let us just shift everything left. Yes, much better. We have now proper space to work for the value of w. Okay, now how would we get w? If we take this triangle, I see this w is what? If I draw it over there, w, if I take the 10 of this triangle, the tangent, 10w is going to be perpendicular upon base, that is t upon 5, isn't it guys? The 10 of this angle, the tangent of this angle is going to be t by 5. So that is what we are going to write over there. Now 10w degree is going to be t upon 5, right guys? We know this, and we just found out the value of t. So we are getting 10 of w degrees equals to 1.055 upon 5, isn't it guys? Let us take the inverse of this. So if I do this, I'll get w degree equals to 10 inverse of 1.055 upon 5, right guys? If I even further solve it, solve it like this. This 5 is definitely going to cancel this 1.055. So we will get 0.211. So we need to find out the 10 inverse of 0.211. Let us again use our calculator quickly. And when we do so, 10 inverse 0.211, that is resulting into 11.9. So this W, or the angle, is 11.9 degrees, isn't it, guys? We just got the value of W. Let me just check it one more time. Yes, it is 11.9. So this is what is the desired value. And you can see that this question consists 7 marks, guys. It's among the, the most, I should say, the valued question in this whole paper. This single question is of 7 marks. So we need to be very careful about the steps that we choose to write. We have started with solving the, Pythagoras theorem and getting the value of t. We got the value of t by using the quadratic formula. We got 2 values of t, wherein one value was negative and the other was positive. So we took positive as the height could not be negative ever. And then we used the concept of trigonometry to get the desired value of angle W. And what is the answer, guys? We have it as 11.9 degrees, right? Note it down for a reference. I know it's quite a long solution, but you need to write it. Please note it down. I'm giving you 1 minute. Yeah, please go ahead. Yes. So we are done with this question number 6, and now we are going to start the next question, that is question number 7. So yes, dear students, let us move to the next question, question number 7. This question, if I look at it, is again related to trigonometry. The previous question was from basic trigonometry. This is from further trigonometry, right? So if you look at it, we are being given with a diagram which shows the right angle triangle PQR on horizontal ground, and X is vertically above R, and the angle of elevation of X from P is 21 degree. XR is given as 2.8 meters, while RQ is 7.1 meter, and we need to find few missing dimensions, or I should say the values. So if I enlarge it, this is what it looks like. We have this triangle PRQ on horizontal ground, whereas this RX or XR is vertically placed over it. Just think about it to be a triangle, right? This is kept horizontally on the ground, and this is XR vertical to it, right? This is what it looks like. So here what is being given, let us first of all draw few things very important. Here we are being given that the angle of elevation of X from P, that means of this X from P, let us draw. This angle of elevation is given to us as 21 degrees. Let us write it over there. This angle is 21 degree, right? What else is given? We are being given with XR equals to 2.8 meter and RQ as 7.1 meter. We have to find the angle of elevation of X from Q. That means let us join this QX. This is what the elevation from Q to X looks like. So we need to find out this elevation, this angle. This needs to be found out. Okay, guys. So for your reference, I am going to make this triangle again. That is XRQ, and let us make it as a right triangle. Triangle XRQ is given, and this is 90 degree for sure, and XR is given to us as 2.8 meters, while RQ is 7.1 meter. We need to find out angle RQX, this elevation. Let us take it as theta. This theta needs to be found out. Let us use the basic of the trigonometry. We know that we can use the tangent of this elevation, tan theta here in triangle XRQ. Tan theta, the tangent of this theta will be perpendicular, that is XR, upon base, that will be RQ, and when I substitute the value, XR is 2.8 meter while RQ is 7.1 meter. This meter is gone. So if I take the inverse of this 10, this becomes 10 inverse of 2.8 upon 7.1. So we just need to find out the 10 inverse of this value. Let us quickly use our calculator for the same. Here we have our calculator. So when I find it, I will first find out 2.8 divided by 7.1. So 2.8 divided by 7.1 gives us a 0.39. So we are getting it to be 10 inverse 0.39. So we need to find out the 10 inverse of 0.39. Let us get it. 0.39, and 10 inverse of it is 21.3. So we are getting the angle of elevation as 21.3 degrees. So this angle of elevation from Q to X is 21.3 degrees that we have got. This question was quite easy. Let us put it over here. The angle of elevation of X from Q is 21.3 degrees. I hope it is clear to all of you. Please note it down so that we can move further. This question or this part of the question was related to this triangle XRQ. Now moving ahead, we see here that we are being given that the diagram is same, the question is same. We have to find out this PQ. This PQ needs to be found out. So for that PQ, we need to do few important things. That I am being given with RQ already. It is 7.1 meter. If somehow I get PR, I will be able to find out PQ by using Pythagoras theorem. So to find out PR, we need to do some important things. I am again drawing it. We know that the angle of elevation of X from P is 21 degrees, isn't it? This thing is 21 degrees. Right? So let us use this triangle XRP. Let us draw it again for our reference. This is another right triangle. This is what it looks like, guys. This is a triangle XRP, where this angle is 90 degree. What else is given to us? We are being given with XR to be 2.8 meters. And we are being given with this angle of elevation as 21 degree. We need to find out PR in order to get the value of PQ. So we will simply use the tangent of 21 degrees in triangle PRX. Tan 21 degrees is equals to XR upon PR. So if I transpose it, I'll get tan 21 degree equals to 2.8 meter upon PR. That means actually PR is going to be 2.8 meter divided by 1021 degrees. Let us quickly find out the value of 1021 and then we will use it. Just a second, guys. So here, yes, the 10 of 21 would be, just a second, I'm just finding it for you. 1021, just a second, yeah, it's taking a bit of time. 1021 is going to be 0.38. It is giving us 0.38. So 2.8 meter divided by 0.38. Let us quickly find out this value as well. So if I divide it, we are going to get 2.8 divided by 0.38. 7.38, that results into 7.37. It is 7.37. So the value or the length of PR is 7.37 meters, right? We just got the value of PR. We will use it for the triangle PRQ to get the value of PQ. I'll just reduce this size. Okay. Now, in triangle PRQ, guys, we just found out one very important value. This PR is 7.37 meter, and here we have RQ as 7.1 meter. Better would be to take this 7.37 as 7.4, but we can use it like this as well. So here, if I further solve it, we know that in triangle PRQ, PQ square is equals to PR square plus RQ square. This is by Pythagoras theorem. So PQ square would be equal to PR being 7.37 whole square plus 7.1 whole square. So this could be PQ square equals, so just quickly find out these squares, add them, and then we will get the answer. So here we have 7.37 square. So 7.37 square is 54.3, and 7.1 square, 7.1 square is 50.41, and if I add them, look what am I going to get. This is going to be 104.71. so that means to get the value of PQ, we'll need to take the square root of 104.71. that would be in meters now, because this was in meter square. So if I take the square root, meter will come out. So let us quickly find out the square root of, let us find out square root of 104.71. So guys, we are getting it as 10.23 meters. This is what it looks like. It is 10.23 meters, or we will write it in three significant figures. So it will be 10.2 meter, right? That is what is the answer. 10.2 meter is the length of PQ given in this triangle. I hope you are clear. You need to note it down properly. We are using all the basic concepts of trigonometry over here, and then we got this value. Moving ahead, the next question, that is part B of this. This is altogether a different triangle. Let us look at it. Calculate the acute angle KML. Acute angle KML. Where do we see that angle? KML. This angle. Guys, this angle is not known. We have to find it out. How would we get it? This triangle is not at all a right triangle. This is, an acute angle triangle. Here we are being given with two of its sides. ML is 9.1 centimeter, while KL is 16.7 centimeter. We are also being given with one of the acute angles, that is 32 degrees, right? That is angle K. So we need to find out angle KML. What should we use, guys? We know one thing. We know the sine formula. Sine formula is what? Sine of an angle upon the length of the side opposite to it is equal to the sine of the other angle upon the length of the side opposite to it, and so on. What do we know? If I write sine formula, what is sine formula, guys? We know that sine of angle A upon A is equals to sine of angle B upon B equals to sine of angle C upon C. So we are using this formula. So we are going to use this formula to get the value of m. In triangle KML, have a look guys, sine of K upon the side opposite to it is ML would be equal to sine of M upon the side opposite to it being 16.7. I'll just write its dimension, that is KL, right? This is going to be equal to this. Let us substitute the values. Do we know sine K? We know the value of K, so it is going to be sine 32 degree upon ML. ML is 9.1 centimeter is equal to, do we know sine M? No, not yet. Upon what is KL? It is 16.7 centimeter. Okay, so if I further solve it, I'll get that sine M is actually equal to sine of 32 degrees upon 9.1 being already there, and then we have transposed 16.7, so it will be multiplying this fraction. The centimeter and centimeter is gone. Let us quickly find out this. We have to divide this 16.7 with 9.1. Let us do that quickly. 16.7 divided by 9.1 is giving us the value as 1.83, and also we need to find out sine 32 degree. I'll just do that. Let me first write this. We can round it off to 1.84, and we need to find out that what is sine 32 degrees. Let us quickly find out. Sine 32 degrees is 0.53. Okay, so this sine 32 is 0.53 and 16.7 divided by 9.1 is 1.84. Let us quickly multiply them and get our answer. So we are getting 0.53 multiplied with 1.84, and we are getting it as 0.98. And then we need to find out the inverse of this to get the angle M. So angle M is sine inverse of 0.98. Let us quickly find out. 0.98. That results, guys, into angle M being 78.5 degrees. This is what this acute angle KML is. This is 78.5 degrees. Right, guys? That is the acute angle KML that we were supposed to find out, and that is what is the answer. I hope you are clear and in the know about the sine formula. That is what we have used in triangle KML, and we got the desired value. Note it down so that we can move ahead. Okay, so moving ahead, let's see what is being given. Oh, it's a nice question. The area of triangle ABC is 62.89. That is what is given to us, and 62.89 centimeter square to be specific. So area of the triangle ABC is already given to us. That is 62.89 square. Show that the angle BAC is equals to 28.4 degrees, correct to 1 decimal place. So guys, we need to show this, that the angle, this angle BAC is 28.4 degrees. This we need to prove. How can we prove it? If we talk about only triangle ABC. So in triangle ABC, we are being given with AC and AB, and we are not being given with anything else. So do we know a formula related to it? How would we get the area of the triangle associated with this? We know a formula, that is 1 by 2 times AB times AC times sine of angle A. That is what is the sine formula used to find out the area of the triangle, isn't it? So let us use that sine formula that is appropriate over here to get the area, and then we will find out whether that angle A comes out to be 28.4 or not. Right? Let us just make a bit of space for our working. Now, what are we being given with? In triangle, let us change the color. In triangle ABC, AB is equal to 12.3 centimeter and AC is equal to 21.5 centimeter, and area of ABC is given to us as 62.89 centimeter square. Okay, since we know that area of triangle ABC is actually equal to, let me make it small. Yeah, since the area of triangle ABC could be found out by half multiplied with its base AB times, since height is not given, so we will take AC multiplied with sine of angle A. That will be treated as the height of this. So half times base times AC sine A will be equal to the area. So what is the area? Area is 62.89 centimeter square is equal to 1 by 2 multiplied with AB being 12.3 times AC, that is 21.1. That all is in centimeter. So let us first of all mention it. 12.3 times 21.5 centimeter times sine A, and we will find out this angle A only. So here if I use it, I will transpose this 2 to the other side. So it is 62.89 multiplied with 2. This centimeter square cancels this centimeter and centimeter. So the units are gone, and we will bring down 12.3 and 21.5. This will be equal to sine of A. Let us quickly solve it, guys. What would be 62.89 times 2? Let us do it orally. 9 times 2 is 18. Carry it forward 1. 9 times 2, 8 times 2 is 16, and 1 makes it 17. So 2 times 2 is 4 and 1 is 5, and this is going to be 12. So it is 125.78, and then we will find out the product of 12.3 and 21.5 using our calculator. So that is 12.3 multiplied with 21.5, that is resulting into 264.45. Let us write it. 264.45 is equal to sine A. So if it is the case, we can find out the value of angle A by taking the sine inverse of 125.78 divided by 264.45. Let us quickly solve it, guys. We again are in the need of using our calculator. So here what would we find? Let us first find out the quotient of 125.78 divided by 264.45. So it is 0.48. So I am in the need of finding the inverse of 0.48, and let us quickly get the inverse of it. So the inverse of it would be 28.7. So this angle comes out to be 28.7 degrees. So it is nearly around, as I told you, this is coming out nearly around 28.4. 28.4 degrees. That is what we needed to show, and hence we can write hence proved. Right guys, this is what this angle A is about to be. Please note it down for your reference, and then we'll move to the next part of this question. Changing it now. So here, yes, we need to calculate BC. Again, the area is given to us. We have to find out the BC side of it. For that, again, we can use the formula. We know about it. So the formula to find out this side BC, let us look at this triangle first of all. In this triangle, if I see, let us just shift it a little bit. Yes. So here in this triangle ABC, to find out this BC, we can devise a formula. The formula for that would be, in triangle ABC, BC square is going to be equal to AB square plus AC square minus twice of AB times AC times cos of A. This is what the formula looks like. BC square is equal to AB square plus AC square minus twice of AB AC cos A. And are we in the know about these dimensions? Let us quickly put the values. So here this implies that BC square is equals to AB square, that will be 12.3 centimeter square, added with AC square, that is 21.5 square, minus twice of AB, so 2 times AB being 12.3 and AC being 21.5 times cos of A. Cos of A is nothing but cos of 28.4 degrees. That is what we need to find, guys. Let us quickly substitute, or I should say, solve for this. What will be 12.3 square? Let us quickly use our calculator to get the values. So 12.3 square would be 151.3, or we will take it to 2 decimal places. So 151.29 is the square of 12.3 added with the square of 21.5. So 21.5, its square is 462.25 minus 2 times 12.3 times 21.5, that results into 528.9, and also we need to find cos of 28.4 degrees. So that is going to be 0.88. So we will do this 528.9 multiplied with 0.88. That is what this looks like. So yes guys, let us just quickly find out what will be the product of 528.9 and 0.88. For that, BC square is, the sum of these two would be 613.54. We use the calculator for that, and this is 465.43. And when we get its difference, we are getting it to be 148.11, right? So to get the value of BC, we will find out the square root of 148.11. Let us quickly find out the square root of this. So square root of 148.11 is 12.17. Or if we round it off, it will become 12.2 centimeter, guys. So this answer is 12.2 centimeter. I hope you are clear with this calculation. So please note it down, and then we'll move to the next question. So this is the next part of the same question. we have to find out a missing value wherein when AB, this side AB is extended to a point D such that the angle BDC is equal to 90 degree. Calculate BD. What has happened, guys? When we see over here, this side AB is extended to point D such that when this D is joined with C, angle BDC is 90 degree. Right? We have to find out the length of this side BD. This BD is not known to us. If we talk about, have we already found BC? Yes, we have found out BC. Let us look, what did we find BC to be? So here BC is 12.2 centimeter, right? Let us write it over here. BC being the hypotenuse of this right triangle CDB or BDC, whatever you want to say, is 12.2 centimeter. We need to find out BD. If, guys, somehow we get the value of this CD, we will be able to find out BD by using the Pythagoras theorem, right? So let us first of all try to find out CD. To find out CD, I'll consider the full triangle ADC and we will use the sine angle because we know that this angle is 28.4 degrees. That was given to us. We just proved it to be that, isn't it? In triangle ADC, have a look, guys. In triangle ADC, sine of angle A would be perpendicular upon hypotenuse, perpendicular being CD and hypotenuse is AC, isn't it? Let us substitute the values. A is 28.4, so we will write sine of 28.4 degrees is equals to CD upon AC is 12.2 centimeter. Let us write down CD. CD would be the product of sine of 28.4 degrees with 12.2 centimeter. Let us quickly use our scientific calculator to get the answer. So sine of 28.4 degrees, guys, if I try to find it out, sine of 28.4 is coming out to be 0.48 and this needs to be multiplied with 12.2 centimeter. So if I solve this, I am getting it as 0.48 multiplied with 12.2. This comes out to be 5.86 centimeter. So the length of CD comes out to be 5.9 centimeter. I'll mention it over here as well. That is CD is equals to 5.9 centimeter. But what do we need to find? We need to find out BD. So now we will use Pythagoras theorem in the triangle BDC. Let us use it. Now, in triangle BDC, what we are going to use? We will use the Pythagoras theorem that will tell us that BC square is equal to BD square plus CD square, and let us substitute the values. What is BC? We are getting it as 12.2, so 12.2 whole square. What is BD? It's still not known. We are about to find it out. And CD is 5.9, so it is going to be 5.9 square. Let us quickly find out. If I further solve it, I'll find out BD square to be equal to the difference of the square of 12.2 and the square of 5.9. Okay, let us quickly use our calculator to get the values. So here we have 12.2 square, that is equal to 148.84 or 148.8 we will take. BD square is equal to 148.8 minus 5.9 square, guys. 5.9 square would be 34.8. So what is going to be the difference? if we find out the difference, it is going to be 148.8 minus 34.8, that is 114. So the square root of 114 will give us the length of BD. So let us quickly get its square root. So we are getting it as 10.7 centimeter, guys. So this gives us the value of BD to be 10.7 centimeter. Let us write it. BD is equal to 10.7 centimeters. So this is quite an interesting question. This question 7 covered all the concepts of the trigonometry as well as the triangle. That is what we have used, and we have got the required values. Note it down for your reference, and then we'll move to the next question.